Okay, this is Mrs. Wilkoskis. We are still Saturday, April 16th. I'm going to do one or two more of these, and I certainly don't expect you to watch something that you already understand. This is really for those who don't understand this, because I know you guys really, from what I understand, you really haven't been lectured on this subject. Okay, so now we're going to talk about hydrogen ion concentration, how it relates to hydroxide concentration, and how they relate to pH. Okay. We talked in the video on the ion product constant that the product of these two always equal 1 times 10 to the negative 14th. Okay. And when one goes up, the other one has to go down because this is a constant. If this one goes up, this one has to come down. So you can determine whether if a solution has more hydrogen ions than hydroxide ions, then it's acidic. If it has less hydrogen ions than hydroxide ions, see, then it's basic. Okay, you probably already know that, but you do definitely want to think about it in terms of that. So if this is higher, it's acidic. If this is higher, it's basic. Okay, so we've talked about this. Now we need to talk about pH and pOH. Let's focus on pH. And in reality, people deal with pH far more than they deal with pOH. I've actually never seen anything in scientific reports reporting a pOH. However, sometimes it's easier to calculate a pOH and then move it to the pH. And so it's nice to know, because it's a quicker method to go from here to here than going this way. And I'll show you in a minute. Okay, so the reason we use a pH scale, that P, think of it as power or exponent. It's the power or the exponent of the hydrogen ion concentration. Ah, that's the exponent. There you go. We're talking about that exponent. Okay. pH scale is a logarithmic scale, which is a non-linear scale to describe something that covers a very large range. Okay. So you're talking about something that goes from a molarity of 1 to a molarity of 1 times 10 to the negative 14th. That may not seem like a large scale to you, but think about it like this. Hold on, I wrote it down somewhere. There we go. If something has a pH of 1, it has 0.1 moles per liter. If something has a pH of 13, that's a decimal there. It has that many moles per liter, which isn't very, very much, okay? There's a huge difference between those numbers, an order of magnitude of 13. And that's that large range we're talking about. I hope I have my decimal points right, but the point is the difference, not so much that my decimal points are right. I hope they're right. Let me pull up let's go back to this. Okay, so if you need the pH, all you're doing is taking negative log of the hydrogen ion concentration, and basically that's you're determining what would be that exponent. Okay, so you get your calculator out. I do not have one of y'all's jam up calculators, but you would that you guys typically have. Actually, this is my daughter's. Now I'm trying to even figure out log. So I would say negative log. Oops, I bet I have to do log. Actually, I do not know how to use this calculator. I'll figure that out. Then I'll come back. I just grabbed it for my daughter. The hydroxide ion concentration to the pOH is negative log of the hydroxide concentration. Okay. To convert pH to pOH, it's just pH plus pOH equals 14. Just like this times this equaled 1 times 10 to the negative 14th. Do you remember way back in algebra, pre-algebra, when you wanted to combine like terms with different exponents, you could actually add the exponents? That's what this is doing. We're adding those exponents because this is just an exponent. This is just an exponent. Okay? So if you are given a question that asks you pH to H plus ion, to go backwards, you would say the hydrogen ion concentration is 10 to the negative pH. pOH back to hydroxide ion concentration is 10 to the negative pOH. Okay, so that's how you work these problems. and we will work some of these problems in the next video after I figure out how to work my calculator. I won't make you watch me try and figure out my calculator.